Hi, my name is Brian Capo, and welcome to this week's Ask Brian, part of our weekly newsletter. This week it's going to be a bit of a double feature because I was delayed last week, so I'm going to have two this week. The second of this week, the one I'm doing right now, is going to be a little bit of an olio of a bunch of questions in order to catch up. So let's get right to it. The first one, I got a question asking, what is doing theoretical statistics like? Well, a good answer to that for me would be I don't know because I don't do that much theoretical statistics. But let me expand on that. So I've done some things that are a little bit theoretical and methodological, and I would say first thing you need a lot of training. And this sort of stuff isn't like riding a bike where if you quit doing it for a while and you get back on it, it's just like you never quit doing it. Theoretical statistics, you basically need a lot of training and you need to do it consistently for a while. The training you need to be well trained in mathematics and theoretical statistics. The second thing is almost all theoretical statisticians have some sort of anchor point that they work from, so a collection of theoretical results that they know quite well. For many statisticians, this boils down to some combination of asymptotic theory and optimality theory. Okay, so another aspect to doing theoretical statistics then is finding areas to apply it to, finding novel settings. So I think the best theoretical statisticians are able to broaden their base of theory quickly and apply it to new settings, apply their existing theoretical skills to new settings rather quickly. So if you see the really top places and the top people, they either have a common set of skills that they're adapting quite commonly, but they're really kind of jumping on new technology or new measurement very, very fast. So you saw this, for example, when genomics was just getting started and microarrays were just coming about. You saw a lot of people all of a sudden jump on the so-called small n large p problem and make some good headway with that, both in terms of multiple testing and in terms of estimation. So, anyway, that's a little bit about doing theoretical statistics. Okay, so let's see. So the next question I'm looking at is what kind of jobs are at the intersection of health and data science? Okay, so if you define health as both medicine and individual health and all these other kind of patient care aspects of health and public health, right? One of the best jobs is to be a biostatistician, which exists in both these areas. To be a biostatistician, you need to be trained as a biostatistician from a biostatistics department. There's some other ways you can work in the health field as well. When I meet with anyone over in the hospital and doing medical research or individualized patient care type research, they're always really desperate for more technical people of all sorts. So biostatisticians are one, and analytic people, machine learners, that sort of thing, data scientists. They're always in need of people who have those kinds of technical skills, but then also speak enough of the language of health or public health in order to be useful. There's a lot of need for people who do data engineering and informatics. At any rate, what I can say in the health arena, and this including public health, the demand for technical people with computer skills and so on, so far outstrips the supply that you can kind of pick your poison and pick a lot of different areas that you can go into. Again, like I would say, I think one of the better ones is biostatistics, but like I know also several people that work in informatics and data processing, right? There's a lot of need for people who can say take raw images and do some basic image processing in radiology, or there's a lot of need for people who can do basic processing of genetics and genomic data. Now again, biostatisticians work on these sorts of problems, so you can study these sort of things from a biostatistical perspective. Okay, last question I'll handle today from the queue of ones I'm trying to clear out. It says, what programming skills should a data scientist know other than R? First of all, I don't even know that you need to know R to be a data scientist. I think you can be a good data scientist and just know Python well and maybe a little R instead of knowing a lot of R and a little Python. So, but let's assume you know R well, and what are the things you might learn. So I think obviously you need to know things like Git and GitHub, and those aren't so much programming skills as programming utilities, but certainly all these sorts of programming utilities you need to know. I think it's always good to know some Unix shell scripting, so probably Bash would be my preferred Unix shell that I would suggest to work with. And then also I think you need to know some basic Unix computing. You don't need to be able to install Linux on new hardware because people just kind of don't do that as much anymore. But it would be a good idea to be able to spool up a server on Amazon or spool up a server on DigitalOcean and be able to work with a Unix computer that way. And if you know some Python, then maybe you don't need to know some Bash scripting, because Python can both do some of the data analysis things, but also I think a lot of people will replace some of their shell scripting with Python scripting. A computer language that I think is highly complementary to R. So Python, in terms of data analysis, has a lot of overlap with R, so it's not very complementary. But a language that I think is very complementary is JavaScript. So if you work in anything like interactive graphics, knowing some JavaScript is great, because R can do the heavy lifting of analysis and creating the graphics, and then JavaScript can be the display and making it interactive and embedding it in the web page and all those other sorts of things in a way that R can't. And if you look at some of the really cool R things going on, some of them interact with JavaScript. Probably be nice to know some amount of a database language, and to be able to write some low-level compiled code would be another useful thing. If you can do some C or C++. And I think probably the best way for a data scientist to do those sorts of things is to maintain R, Python, or whatever you're using as the skeleton of the program, and make kind of function calls out to compile code like C++ or Fortran or whatever. Most people seem to use C++ these days. So those would all be good, but I don't think you need to know all of them, but certainly some of them. I think probably I would prioritize at least the Unix computing more than anything else, since that seems so relevant. But I know a lot of data science places that work primarily in Windows, and at what point does what does the Unix computing really help you then? But then I would say you need to know some of the really equivalent low-level. If you're a real like hardcore Windows shop, you need to know some low-level Windows stuff. So if you're in that kind of environment and you've never edited a Windows registry or stuff like that, you probably need to know some of the more deeper internals. If you never worked with PowerShell or anything like that, then that's the equivalent of knowing Bash, right? So you'd want to know the equivalent of that sort of thing on Windows. Okay, so anyway, that clears out the queue a little bit. There's still a couple more, and we'll have another video next week. Subscribe, sign up for the newsletter in the YouTube description below. Leave a comment if I've forgotten anything, and recommend some other programming languages and computer skills that you think data scientists should know. I'll have a next video next week. Hopefully I won't be sick, and I'll see you then.